Well, good morning. It's Keith here. We're going to be starting the stream very soon. Firstly, I'll just give you a bit of an introduction. Firstly, I apologise the stream is slightly earlier than was sort of scheduled. I scheduled it for past. We're starting a few minutes early. I originally wanted to start it at 5:15, but for some reason the interface I created the stream on was set up differently. YouTube is always in a state of flux. There's multiple ways of doing the same thing and they all work differently. So the one that I created it on yesterday only offered half-hour increments, whereas the one I usually use offers quarter-hour increments. I'm not sure why that is, but anyway, there's a couple of people watching, I think, and if there are, then no matter, we'll just carry on regardless. So what we're going to be doing today is we're going to be doing some 65816 assembly. In addition to that, I've got my Halloween stream scheduled tomorrow, so if you're around for that, please watch that. We'll be playing the Seventh Guest and discussing the technical design of a game like that. So if that would be interest to you, please join me for that. So as I say, today we'll be doing 65816 actually on the Super Nintendo. So let's actually start the stream and have a look at what we'll be working with. So this should look pretty familiar to you. This is my Notepad++ as usual, but this version has actually been configured quite differently. We're actually going to be doing 65816 with this one. So let's just fire this up and let's see our Hello World running. Now this is a modified version of the Hello World that I've shown in the past on the Super Nintendo. This version is actually going to be running in full, potentially. Ooh. Well, that's not very good, is it? What on there? I'm not having. I tested this a moment ago and it worked absolutely fine, and now it's not working. Okay. Now I have a hunch that this is nothing to do with the code at all, and this is actually the video capture and the emulator playing up. Because as I say, this worked fine. Maybe not then. Maybe it isn't. I thought this worked fine a moment ago. Okay, anyway, so we've got a running example here. NMI, what's NMI, sorry? Non-maskable interrupt would be my understanding of that. Anyway, good to see you here, Joel, but thank you for joining me. So we're doing some 65816 here. Right, so this is a Hello World example, but based on the original one. But you can see we're now showing the accumulator, which is now labelled C as 16-bit, X and Y as 16-bit. And yeah, so I don't understand what you mean linked to the live stream. So if you mean if you search for non-maskable interrupt, sorry, is that what you mean? So we've got these new macros here, and these define how the processor mode is set, because you can set the processor into all kinds of different modes, which makes it very confusing. Firstly, you can turn on the 16-bit functionality as a whole using this option here. That will allow you to actually use 16-bit addressing and the extra commands. Some of them work in 8-bit mode as well, and then you turn on the accumulator for 16-bit addressing and the XY register as two separate modules. Okay, sorry, jokes don't transfer well across chat sometimes, and especially not at 5 a.m. I'm distinctly lacking in sleep this morning. So we've got these that we can play around with here, and I've been having a play around, and I guess that whatever I did was breaking it. I don't quite know how, because I was sure it worked fine last time I did it, but anyway. I was testing switching to 8 and 16-bit modes and changing some of the registers in 8-bit mode to see how it affected the registers, and essentially if you switch to 8-bit mode you lose the top byte of the Y, X and Y registers, but the C register, the 16-bit accumulator, doesn't change. Now, what I would like to do today is I'd like to play with the MVN commands, because these are like the LDIR of the 65816. So these are a new command that we've never had before, and so I'd like to try them out. I mean, here, if you're not familiar with it, here is the full set of commands here. So, I mean, most of them I think are. I mean, we've got these push absolute address, push effective indirect address as well. We should maybe have a go with these. I mean, some of these are related to the data bank and things. This is how the processor has been extended from a 16-bit addressing bus to a 24-bit one. But a few of them we've had before. PHX, those are fairly mundane. But the reserve for future use command, very strange. XBA, I've not had a go with that. Let's have a go with that as well. So if I just move my documentation out of the way here, and let's have a look. So I need a memdump. Memdump, here's one. Here's a nice memdump. We'll have this. So if we dump $8,000, and if we also dump the start of our program, let's see what that looks like. So I got back into, because I wrote the original example a long time ago, but I got back into I've been trying to use the Phoenix 256, which is another of these 1, 2, 3, what's going on here? I've got so many test programs I can't work out what's actually going on here. The Phoenix 256 uses the 65816, and because of the way the video memory is mapped, it's not so much you can use it as more you have to use it. There we go. So something in my code was actually crashing the processor, so I need to look into that further. So we got, that's not right. Why is dumping it? Am I running from 8,000? I guess I'm running from 8,000. I didn't remember that. Okay. So the first thing I need to do then is, I can't remember where the RAM is on the Super Nintendo. So let's have a look at www.chibiakumas.com 6502. Hopefully I've put a memory map on my... Why is it going to snippets.cd and .mozilla? It drives me nuts if it does. Okay, so my computer is running so slow this morning. For some reason the video capture is taking 30% of the CPU this morning, whereas it usually takes 15. I don't know why that is, but I've been having more USB problems again, just to keep me on my toes as well, so who knows why that is. I think I'm being punished for trying to run external video displays and keyboards off my laptop here. So Super Nintendo, here we go. Here we go. 8,000 cartridge RAM, so that's why. So it looks like 2,000. Oh, okay. So, right, okay. So let's try the 1,000 range then. Let's try the 1,000. So what I want to do here is I want to copy from my memory of my program code into the RAM as a test. So, but I can't remember where the RAM is because it's been so long since I programmed the Super Nintendo. That doesn't look like RAM, does it? User RAM 200. Oh, okay, it probably is RAM. I'm forgetting. This is a different emulator to the other one I used. This is a more advanced one and it's stricter. And one of the weird things it does with its strictness is, makes a lot of sense, but it's a bit of a surprise. It writes random data to RAM when it powers up. So rather than everything being zero, it's complete garbage. So if you don't zero it yourself, your program's not going to work properly. It's to make sure your programs are going to... It's being thorough. It's a good idea, but it's a bit of a shock when you expect to see zeros of RAM and you're seeing what looks like maybe program code or something, but it's not. It's random data. So what we'll do then is let's try this mvn command block move next. So how does it work? The source, destination and length operands of the instruction are taken from X, Y and C. These should be loaded with the correct values for execution. The source address for MVN is taken from X. Okay. Should be the starting address. The destination should be in Y for the move block. The length should be C, which is the accumulator. The length loading. The M flag is the 16-bit accumulator. Now the only thing that confuses me is it says syntax source block destination block. Excuse me a moment, just going to sneeze here. Sorry, I just had to get a tissue there. So what's this source and destination block? I'm a bit confused by that. Does that mean we need an extra byte here for the 24 bits? Could do with an example there. Number of bytes 3, opcode 54. The 2 put-upon bytes in specify the banks holding the 2 memory blocks. Yes, sir, that's correct. 5 a.m. Yeah, I'm insane, aren't I? You know, the terrible thing, I have this, Sam's commenting that I'm getting up at 5 a.m. The weird thing is, if I decide to get up early, I kind of become so concerned that I'm oversleep. I actually wake up even earlier. I've woken up on the hour, every hour for about the last 3 hours or something crazy. I might as well have just got up at 2. It's ridiculous. But anyway, as I say, yeah, I used to get up at 6 a.m. just in general, because it sort of helped with sort of work and things. But 5 a.m. is a bit rough. I'll be honest. I've been struggling a bit with it, but I was trying to do an early morning stream before work, because after work most of the other territories I think won't be available. So I've been giving it a go, but as I say, it's a little bit difficult. So let's try this. MVN. I do start to feel a bit like I'm jet lagged or something, unfortunately. MVN, but it does. I was doing some programming last week on this stream, and I got a load of work done, but I was like, I can't remember anything I did. I was so tired, I couldn't remember what I was doing. I'll probably find I've been coding rubbish all morning and didn't remember it. So we need to switch everything to 16-bit then, I think, here. We need to actually go into 16-bit mode. So, see that. Just double check that. Oh no! Oh no! My monitor code doesn't work in 16-bit mode. That's why I tested it. I wasn't sure if it did. This is what's such a pain about the 65816. I give it credit where it's due. You know what they've done is very clever. You know, making a processor work in a 8-bit and a 16-bit way, but you've got, you know, it's hard work programming. Just programming an 8-bit to a 16-bit processor. And now you've got this weird combination of the two, and it's like, you know, it's 30% slower for the processor compared to the 68,000, roughly speaking. And it's about 30% harder as well, and it's hard. You know, this stuff's hard enough already. You know, we don't need things making harder. Thank you. But so I'm going to load 50 bytes. Did it say X was my source and Y was my destination? X is the source. So I'm going to load from my prog. And I'm going to write to hexadecimal 1000. So if this works, it should copy from the first memory dump to the second, from the second memory dump to the first. It should both be the same in effect. Error. Could not process LDY out of 8-bit range. Well, we should be in 16-bit mode, so what's gone wrong there? So it was happy with line 24, but it's not happy with line 25. So let's have a look at my... Let's have a look at what's going wrong there. Basic macros. Index 16. Now I thought that was going to set. I've put X, but it's actually X and Y. Oh, okay. I'm using the wrong one. Let's use this one. I think we need to use this one. I'm forgetting what my own macros do. That's the joys of 5 a.m. programming. So the Phoenix 256 anyway. So I've been trying it again. I was. So that looks like that's worked quite nicely, doesn't it? That's a nice command. So that's copy A bytes from N1 colon X to N2 colon Y. That was MVN. Let's move next, and there's another one. So if I change this to just 8, let's do 8. So now the first line has copied, but the rest is just random still. So that just confirms that works as we expected. So that's quite nice to have. Surprised that was the thing they decided to do, though. I mean, as I can understand it being a useful function, but if you were going to, if I was going to pick a bunch of commands to add to the 6502, I'm not sure that would have been it. Anyway, I keep trying to talk about the Phoenix 256. I did some more work on it. I made some very slight progress, got the screen size configured better, and then I came across yet another processor bug. I was trying to make a command that would calculate screen position so I could start defining fonts and things, but when I was trying to add a 24-bit number to a 24-bit number, it wasn't working, and it was because the 0 page, when you add with carry to an entry in the 0 page, the carry flag of the processor wasn't being set by the emulator, and I'm pretty certain that's a bug. I can't see any way that's not a bug. So I reported it on the forum again, and I've had to put it on hold again. It's very, I understand it's very, very difficult to create an emulator, but it's very frustrating when things go wrong like that. My first go-to is, well, I've made a mistake. I assume that I'm at fault, and so I'm sitting there reading over the manual, trying to work out what I'm doing wrong to configure the screen. But then eventually, I do more and more tests, and I realise it's like, no, there's something even weirder going on than that. And eventually, when it turns out it's actually the emulator, and not even just the graphics hardware of the emulator, but even the CPU was actually not working correctly. That's quite difficult. So I'm planning to come back to the Phoenix 256. I'll leave it now until next year. Just give them some time, because there was already a bug with a 0 page incrementing just an entry in the 0 page, and now there's this one with the carry. I'm amazed it's able to boot the ROM if the processor's got that many bugs in it. I guess maybe it's because I'm using it in 8-bit mode. Maybe it works fine in 16-bit mode or something, but as I say, it's very difficult. So anyway, I thought having reread all of the documentation for the 65816, I thought, let's just move on to the Super Nintendo instead, because it's like they're both the same processor, and hopefully this emulator is very robust. So get my skills back up on the 65816. Music copy. Should be the ending address. So this one works backwards. So if we do this plus 24, okay, so what, I can't see what it's done. So 8, 16, 24. So that area there has been copied. Yeah, okay. So if I change it back to NVN, it should copy this bottom line here, I assume. Yeah, there we go. And E2 didn't copy. Okay. So it doesn't affect the byte specified. Okay, that's interesting. Probably says that in the documentation here. Quite interesting commands. Okay, so that's MV and then MVP. They're quite fun. Do we have anything else that we want to try? Co-processor enable. I don't even know if that's relevant to the Super Nintendo. But move, push effective absolute address and push effective indirect address. What on earth does it? Push effective indirect address. So, okay, so they only work with the 0 page. Push effective relative indirect address. Good God. Okay. Push effective PC relative indirect address. Let's have a look at that in the manual. That's a mouthful. Oh, come on. Add the current value of the program counter to the 16-bit displacement in the operand and push the result onto the stack. Okay, I get it. I apologise for keep having to mute the mic. I'm being punished with horrendous allergies at the moment for my sins against programming or something. I don't know. So I'm just having to mute the white mic to wipe my nose and sneeze and things. You're here from a PewDiePie video. How the heck did you find my channel with? Oh my God. Okay, so I've apparently got 85 viewers now, which is a grand total of 20 times my current world record, which is okay. Well, thanks for that. I am now famous. Well, that's great. Thank you for that. We're programming 65816, which is the Super Nintendo programming language here. So I think this is probably going to be a bit confusing for people. Thanks for viewing. If you've got anything you want to ask me, I will try and answer. My channel, I cover classic programming on old computers, Super Nintendo today. Now, this channel is my my work in progress, so I just do live streaming and work on new tutorials. My regular channel, I have pre-recorded much more nicely designed tutorials. So the main one's Chibi Akuma's, so if you go and take a look at that, that's got better tutorials that are pre-done. This is me developing new tutorials for the future live, so that's the difference there. So I'm going to try this PEI. Now, it probably won't make a lot of people probably won't understand what I'm doing here, but in the past I've only programmed the 8-bit processor. But the Super Nintendo is a 16-bit processor, and they added some extra 16-bit commands. So I'm learning how to use the 16-bit commands on stream. The idea is that people who've never programmed before will probably think all of this is magic and don't understand how people can do this kind of thing. And the point I'm trying to make by doing these very sort of semi-amateur, me stumbling along trying to learn how things work kind of streams, is to make the point that it just takes a lot of work. It takes a lot of willingness to make mistakes and to just keep trying if things don't go the way you expect. And so by just turning on the camera and trying to use a processor I barely know anything about, I'm just trying to make that point and hopefully give people a bit more confidence to try things themselves and just see how it goes, So what I'm going to do now is I'm going to use this push effective indirect address, and we're going to push that there. Now, what I want to do next, let's trim all of this out. So if we put a semicolon at the start of all those lines, that will disable those. And then I need to see the current contents of the stack. I'm showing a lot of people in the chat. If anyone wants to say hello or say anything. That's a hard language. Yes, yeah. I mean, to be honest, that's kind of the point. Assembly language is arguably the hardest programming language you can try and do. Now, when I went to university, we covered assembly language for about a total of an hour, and they said that the first thing to know about programming assembly language is don't program it. The point they were making is it's an obsolete language. It's very crude and it's very difficult to debug and things. But if you're doing something for fun, there's usually you're doing it more for the challenge and for the achievement of the procedure. You don't get a color laser print to print out a photograph and go, I painted a picture. You get your oil paints out. You try and draw something from either life or memory. It's the procedure and the difficulty of creating the perfect representation that is the achievement. It's like you see those photographs or you see those screenshots online of someone who's painted in on their tablet or in a graphics package or with a pencil something that looks like real life, and it's the fact that it's so hard to do that is why it's worth doing. And for me, assembly language, while it is the hardest way of programming something, just getting Hello World onto the screen of a Super Nintendo from assembly language means you've had to go through all of the stages to achieve that. You've had to work out the header file format, you've had to work out the graphics hardware, and you've had to understand the format of the pixels in the tile map and things like that. So you've had to go through all of those stages to actually try and understand the hardware sufficiently to do that. And so even the smallest achievement of getting a graphic on the screen, making a sound from the processor, you've had to go through all of that. And even though the end result isn't that impressive, the things you've had to learn along the way are things that are worth knowing. Not necessarily because the Super Nintendo is still worth knowing how to program, but being able to understand the concepts of being able to sort of mentally break down the challenge of understanding the sound processor, working out the waveforms. I had to learn a lot about audio just to get the sound processors to work and things. So as I say, even though the programming language is dead and people aren't going to really want to use it anymore, it's still worth doing, I think. So what I need to do here is what's my favorite project I've done? Well, I mean, I'm just trying to think. To be honest, I'm moving so quickly through the projects at the moment. It's very difficult to say. I suppose I enjoy the graphics programming quite a lot. I mean, it's a bit backwards because often the ones that I find the most satisfying are the ones that went really badly. For example, the Atari Lynx, trying to get sprites drawing on the Atari. I knew you meant assembly, thanks. Best TikTok videos. I only do assembly on these tutorials. the thing with the Atari Lynx is the documentation was really, really bad, and so just getting a sprite onto the screen was a miracle. And so when I achieved it, it was kind of such a relief. It was really something, you know. So, and the sound processor on the Super Nintendo, that's not working, is it? And the Super Nintendo sound processor is completely proprietary. It's not any kind of normal processor. So when I was working with that, I had to actually try and figure out what's going wrong here. I had to actually try and figure out how to program the processor itself, and my assembler couldn't support it. So I really had to really do that in a way that was quite unconventional. And so again, it was kind of like it was very satisfying to see that processor do something, and the amount of challenge that it took to make that work from scratch. Why isn't this working? Okay, I'm obviously doing something very silly here. I know why it's not working. I'm still in 16-bit mode. We need to be in 8-bit mode. Yeah, I do prefer the 68,000 to the 65816, unfortunately, I have to say. Let's push some numbers onto the stack. We should be able to see them at the top of the visible range now. So my viewer count has gone down to 59 now, which is a bit more grounded in reality for my tiny little channel here. So that 66 there is the 66 I loaded. I loaded all these sixes into the accumulator and pushed them onto the stack, and then my memory dump command here is dumping the stack. So the stack goes backwards. So this 6666 here is the 6666 I pushed onto the stack there. So let's just push another one, and then the point of this is that now anything in between these is what I have put onto the stack. Good morning, the Highlander here. Very kind of you to join me. It's nearly 6 o'clock a.m. in Japan at the moment, so my programming has been typically sleep deprived here. To close the old version here. I'm trying to use the PEI command, push effective indirect address. Error, unknown symbol, PEI. Okay. Maybe I'm using the command wrong. Am I misunderstanding what I'm supposed to do with it? Is this another one that needs the 0 page? Yes, it is. Okay. PER, push, that's the one I wanted to use. Push effective PT relative indirect address. Good grief, that's a mouthful, that command is. Let's have a look. Okay, so PER. Let's try PER instead. Okay, so what we've pushed onto the stack 802E, which is the address of my infinite loop here. So where's our stack pointer here? 802D. So yeah, that sounds correct. So that's the current running command, which is the loop here, and I pushed on the label here. So that does sound like it's worked. So that's a useful command. That's quite handy. So that would be for putting parameters onto the stack if we were programming a subroutine. That's quite funny. My viewer count is currently at 9, which represents a record for this channel. It was apparently 320 about 10 minutes ago, because YouTube's algorithm has apparently put me next to someone totally unrelated. So there we go. That's what YouTube does. So you get a bunch of people who come along and go, what the hell's this rubbish, and then leave, which is like, well, can't blame them for leaving. It's not the kind of channel that is going to appeal to that audience. So they'll be watching something more interesting now, I'm sure. So that's a push relative. So we've got push effective absolute as well. Let's push effective absolute. But that works off the 0 page. Is that a mistake? I'm looking at my own documentation and I'm questioning it, because, well, if it works off the 0 page, it's not absolute, is it? It's not. Anyway, okay, well, and that looks like it uses the Y register. Maybe I've made a mistake in my documentation there. Let's check that out. Push effective indirect, direct page. Yeah, I would expect that. Yeah, I've made a mistake. I made a mistake. So that should be, what should it be? So it's not using Y at all. So I've completely ballsed that up. So if I move that across to here, so just save that, that's better. So I don't want that at all. Now this will actually have very little difference from the point of view of executing it here, because if I just push the same label, then it should just run the same, but the actual code will be different. 2E80. So yeah, that worked the same. So is this just a 2-byte command? I guess it is just a 2-byte command then. So yeah, the parameter's 2 bytes, so I can specify $8,000, but it's always going to read from the current bank. The 65816 is it's a 24-bit processor in a sense, but it's not. It's got a 24-bit address bus. Sorry, it's got a 24-bit address bus, but it's not the same. It's not as much of a 20-bit address bus as the 68000. They've split the bus into the address into 2 parts. One is the data bank pointer, I think it's called, and the other part is the conventional address parts. So this is the kind of this is the problem. What am I coding for today? We're doing the Super Nintendo today. Jesus. Actually, more specifically, I'm learning 65816, the 16-bit programming language of the Super Nintendo. I've programmed the Super Nintendo in 8-bit before, but I'm trying to move out into 16-bit for next year. I'm not familiar with the 16-bit side of things, so I'm just experimenting with some of the new commands. If you look at this chart here, these blue commands here are new, and these green ones as well. These are new commands that the old processor, the 6502, didn't have. So I'm just playing with them and trying to learn about them. If you look at my chart here, this cheat sheet is available on my website. But these red ones here, these are only exclusive to the PC Engine. So we won't be using those, but I'm just playing with some of these. So let's try XBA. That that should be a nice easy one. Exchange B and A. So if I load, did you? Yes. Well, yes, that's a very good point. Yeah, I did have a lot of trouble with the other one. I'm now using one I can't remember the name of. Just a second, let's have a look at it. It's WLXA or something. Let's have a look. Utils. This WLADX, that's what I'm using now. Where's my batch file for running this? Oh dear, that's very bad. These tutorials are nowhere near finished yet. So my I was trying ASW and I've not changed the path of the batch file yet. So I'm using this batch file, but it's not ASW I'm using. So these are the commands I'm using now. You can see I've tried T64 TASS, which was pretty good. The only reason I stopped using that was the way I've become used to programming. I use the endef command, the ifndef command, which checks if a symbol isn't defined, and T64 TASS doesn't have that command. And in the documentation they said, look, the way our emulators, the way our assemblers developed is never coming. And I was thinking about it, and they were suggesting a workaround, and it was just like, well, the way I've programmed up until now relies heavily on that command existing, so I can't keep programming in the current way. And I would, the way I've been programming, every time I add a new system to my tutorials, I don't need to change the old code, because I use the ifndef to exclude parts of the code that aren't relevant and are relevant. And without that command, I wouldn't be able to add new systems as easily as I have in the past, at least to my mind. So I had another look around and came across this WLADX, and the reason this one came on my radar was this supports the SPC 700, the specialist processor of the sound chip of the Super Nintendo. So if I ever decided to do a tutorial on that as well, that would help out. Now, it's more than I want, but I accept that it's a good thing. This assembler actually supports very complex bank structures, so you can tell the assembler that for example, on like a system like the MSX1, for example, the MSX1, the cartridges will go from memory address 4000 to C000, and they bank switch within 8K chunks. So if you've got a 128K cartridge, you're going to want to keep half of that fixed, and half of it you're going to want to page in and out as you need different parts of your code or data. And the way I've been doing it is I've just been working it out myself using labels and recalculating addresses to cope with this kind of thing. But with this assembler, you can actually define that within the assembler and say, well, this is the way the memory structure of my hardware works, and it will recalculate all of the labels automatically for you, I believe. But unfortunately, that added the knock-on effect that I actually had to figure out how on earth to get it to just output dumb flat files, because I'm doing it all myself. So firstly, I had to use this linker to just convert the partially compiled assembly into a binary file, and you have to define a text file that does that, but it's very simple, at least in this context. But then you also have to put in this memory map definition and this ROM banking map definition, and then this bank selection to define, right, well, this is my memory map, it's split into these chunks. These are my ROM. This is my ROM map, it's split into these chunks, and this is the current bank and slot of my code. So I had to add all of this to the top, and it took a while to get working. But once I've got this in, it seems that I can just get it to assemble in the exact same way as my other systems have worked, and it works fine, which is very nice. So we're back in business. So at the moment I'm programming for the Super Nintendo. The Apple II GS, I think it was the GS generation that had a 65816, so hopefully I'll be programming for that at some point as well. And the Phoenix 256, I do want to program the Phoenix 256 once the emulator is a little bit more mature. As I said earlier, I was having some problems, there's some processor bugs in the emulator, and it means that there's been a few cases now where I've spent like a couple of hours scratching my head thinking I'm misunderstanding the documentation, and then after more thorough testing I come to the conclusion that I'm actually using it right, and it's the emulator that it's actually bugs in the processor on the emulator, the way the flags work in the processor. So yeah, I say it's completely understandable. It's just a little bit frustrating, and my tolerance is short for wasting my time when I'm getting up at 5 a.m. in the morning to do live streams. Let's put it that way. I don't mind wasting my time because I'm making mistakes. I don't mind wasting my time because I'm misunderstanding the documentation I'm reading. But when I'm doing the right thing and thinking I'm doing the wrong thing, and it turns out to be a bug in the in the emulator, that's quite frustrating to me, unfortunately. So let's try this XBA command. This is apparently going to swap the two parts of what they're referring to as A in this case, which is the 16-bit accumulator. I'm a bit surprised that says A. So yeah, that's worked fine, hasn't it? I should have put another monitor in there. So what we're doing here is we're running a monitor to show the registers, loading, that's in the wrong place, I want to load. So I'm loading the accumulator with 6655, jumping to the monitor, swapping B and A parts. Okay, that does make sense thinking about it. The 16-bit accumulator is called C, you see, so I was getting confused there, but it is logical. Rather strangely, the 65816 calls the 16-bit accumulator, as you can see there, they've swapped over. The 16-bit accumulator is called C on the 65816 and D on the 6809. I don't know why that is, but there we go. I think it's a shame how little success the 6809 had, really. It doesn't seem, when you look at the commands they added and things, it looks like a quite impressive processor. I don't know if it was expensive or I've not exactly checked out the timeline. Maybe it came out just a little bit too late or something, but it didn't really achieve anything. And it was in the Vectrex and the Dragon, and that was about it. But when you read the technical ability of it, it looks very impressive. And the 6309, which rather baffling is a more advanced version of the 6809, even though the number's smaller. I don't know what that's about, but that's actually even better. So it seems a shame they never really got more of a sort of foothold in the market, really. But maybe they were expensive, or maybe they came 6 months too late. It's very hard to tell sometimes if you look at the looking at it from the year 2019. It's very hard to get a full grasp of what was going on back then. I mean, the Sinclair QL is the one that really surprises me. You look at it and you think, well, it's a terrible machine. I mean, from a 2019 point of view, it's a terrible machine. The processor's slow. It's slower than the Z80 in some cases, even though it's sort of 1632-bit. It uses the 68008, which is an 8-bit version of the 68000 processor. Very, very slow. The processor was only used in that one machine, and you think, why on earth? And the hardware is awful. The graphics are ropey compared to anything else 16-bit. And you think, what on earth were they doing? But then you look at when it was released, and you find out that the time they built it, the processor was very expensive. The full 16-bit 68,000 was very expensive, and they got a deal from Motorola for the 6809 very cheap. And the reason they got the deal is I think they were about to discontinue the thing. So they started building this machine in the early 80s based on this processor that was about to be made obsolete. And then all the competitors came out, the Amiga and things came out a few years later with the full processor. They were getting it much cheaper now because the old one was abandoned. And in comparison, by modern days, the Sinclair QL looks ridiculous. But at the time, they were predating the Spectrum. They were using a processor that no one else was using yet for several years, and time has judged them unfavourably, shall we say? But what they were trying was respectable, shall we say? Their plans were reasonable. They just turned out to not be correct with hindsight 30 odd years later. So as I say, it was like, well, I don't think it's fair to say that the Sinclair QL was a bad idea and the Amiga was a good one, because the Amiga was an idea that came many years later and at much, much higher cost. So you're not comparing the same thing there. Anyway. But yeah, the 6809 is not used by anything else. The 65816, a couple of things. But that's, again, even that's another case of hindsight, and plans didn't go the way they expected, because originally the Super Nintendo was going to have backwards compatibility with the Nintendo NES, and you can see that in a few places in the hardware, and the only way they could maintain compatibility was to have something that could run 6502 code, or I know the Nintendo NES isn't quite a 6502, but it almost is, could run 6502 code within the Super Nintendo, and the only choice for that was the 65816. But the 65816 is a much slower 16-bit processor, and I think it was sort of blind luck that Nintendo got away with it, because if it had come down to a processor versus processor fight between the Genesis, the Neo Geo, and the Super Nintendo would have lost quite badly. But it never came to that, because things like Mode 7 and the better graphics of the Super Nintendo's layered hardware, it meant that even if their processor was significantly slower, it didn't matter. It wasn't, and that's been true ever since. It's not about who's got the best processor; it's about whose graphics hardware is the best these days. And ever since the Super Nintendo, maybe even before, I guess. I think the only time that I think there were times in the 8-bit days that maybe it made a difference, but I'm just trying to think. The Commodore 64, that always punched much far above its weight, but I think really that was the more efficient design of the 6502. And I mean, I'm a Z80 fan, so that's kind of the wrong thing for me to say, but the 1 megahertz 6502 in the C64 is able to compete with the 4 megahertz Z80, which it's baffling. I mean, you wouldn't expect a 5 gigahertz x86 processor to beat a 20 gigahertz one, would you? But that's what was happening back then. So, and I think that part of it was that the 6502 from megahertz versus megahertz is about twice as efficient as the Z80. And then the other thing is, I think compared to the Amstrad CPC that I had, the Commodore 64 screen is only about 8 kilobytes, and the CPC one is 16, and that means the CPC has a processor that's effectively around half as efficient and twice as much data to transfer around. And so I think that's why the Commodore 64 would be often said to beat the CPC, and also hardware sprites, of course. So have we got any other command? We've got all kinds of weird commands here that I don't want to play around with at this point. My live chat's not working on my phone here. I wonder why. Kind of just noticed. It's strange. Anyway, I've got 9 viewers at the moment, which is pretty good. I've not much chat, but if people have nothing to say, that's fine. I can continue to talk rubbish for another 45 minutes as required, so don't worry about that. So these are all our old commands, but a few do have new options here. We've got absolute long here. We've got absolute indirect long, direct page indirect, direct page indirect long. Okay. Let's try messing with the direct page. How do we set the direct page? Transfer accumulator to direct page register. Okay, let's have a go with that. No, that's fine. When I say it's a bit quiet, James, it's not me saying, "Hey, why aren't you all talking?" It's me saying, "Oh God, I hope my chat isn't broken in again." So, as I say, you're quite welcome to say nothing. I sort of bill these streams as being I will interact heavily with the chat. No. So Highlander, don't worry. It's not about that. As I say, I just don't want to find out my chat windows broke, which has happened in the past, and that people were talking and they thought I was ignoring them. It's in no way a complaint. I quite often watch people's streams and don't chat because often I'm doing other things at the time. And as I say, from the point of view of these early morning streams, I'm doing something at the time. It's productive work. So even if no one watched it, hopefully I would have achieved something by the end of it. In the case of this kind of stream, I'm actually learning things. In the case of the programming ones, where I'm writing new stuff, it's writing the tutorials. So as I say, there's no problem with people not chatting. It's absolutely fine. So, okay. So let's set the processor to 8-bit. What I'm thinking of doing here is I want to check out that direct page. Now the direct page, in case you don't know, is just the 0 page that's been rebranded. It's lurking. Yes, lurking, I guess. I don't know. I mean that certainly is the term. It's not a term I've heard for a while, and I wouldn't. I mean, you get these streams where there's 1,000 people watching, and if all of them were chatting, it would just be complete anarchy. So I don't think there's anything wrong with that by any stretch of the imagination. So let's. Oh, is it okay? Yeah. I'm going to transfer the accumulator to the direct page, but apparently apparently the direct page is 16-bit. So the direct page register is 16-bit. So but I think it's limited. I think it's limited to I think the top byte of the 24-bit address. Yes, Jesus, I have looked at RISC-V. I bought a book that covered it. I have to say, when I was programming ARM, I didn't like ARM in a sense. I found the structure of the bytecode has changed quite a lot over the years. They keep adding more and more commands, and the end result is quite confusing. And some of the commands have things like inline conditions and the barrel rotator, which is where you can have a register rotate the value without changing the register and then use that as a parameter in an addition command or something like that. And again, both of those things were very clever about ARM, but I found quite hard to get my head around and to program. When I came to RISC-V, both of those things were gone. And I started to miss them. So it was kind of me using ARM saying, oh God, this ARM's more confusing than it should be. I wish I had something simple like 68,000. And then I came to RISC-V, which is like 68,000 again. Oh God, this is too simplistic. I wish I had ARM. So it was kind of teaching me a lesson. One of the things that I found really difficult with RISC-V was there's no command to push multiple registers onto the stack at the same time. Now, I know that necessarily wouldn't be a thing you'd need to do so often, but when I'm writing my monitor tool, which is the first thing I do when I'm developing for a new system, is, I want to protect all of the registers so nothing goes wrong. And it turned into this huge list of push commands for 32 registers or whatever it is. So I think the thing with RISC-V is it will come down to how fast do the commands execute compared to the ARM. Maybe they're faster because the instruction set is very simplistic. The core instruction set of the RISC-V, it's very simplistic compared to the core instruction set of the ARM2. And for comfort, I would certainly program for the ARM. My main interest in RISC-V is that it's basically at this point open source. So, I mean, I don't know if you heard of all of those problems with sort of the ARM chipset and China and things. There was threats that they were going to restrict the export of the license for the ARM chipset. I would like to see a processor that was totally open source gain sufficient foothold to keep the others in check, and I hope RISC-V could do that. But the instruction set does seem relatively primitive. Now, I have heard that the Power PC architecture, because the processor is basically dead now, my understanding is that that's being made open source. So hope that might be interesting. I say you don't want one person dominating the industry, especially if it's owned by a single company like ARM is. Although it's now owned by a Japanese company, so seeing as I'm in Japan, I should probably be. It's owned by SoftBank, the phone company. They were smart when they bought that. So I should probably be supporting them as sort of as showing some local pride kind of thing. But as I say, I'm never a fan of any company owning too large a percentage of the market. I don't think it's healthy. So I would like to see RISC-V do well, but I did find it a little bit difficult. But we are going to cover it next year. It's not too hard to learn because the basic instruction set's very simple, really. But the other problem with RISC-V is with ARM, if you're programming it, you can test on a Game Boy Advance and that or RISC OS. They're both very easy ways, relatively speaking, of making a program and actually seeing it work, having a visual result and having a result that you can feel some pride in the sense of I've made a Game Boy Advance game or I've written a program for RISC OS. With RISC-V, the only thing I had to run it on was a processor simulator. So you're kind of like, well, I programmed a thing that outputs some text on a fake processor. And so, well, it's not really the same sense of achievement, is it? I don't think anyone's putting that on their CV, maybe. So as I say, that was the other thing, is that RISC-V needs a device. You know, there needs to be a RISC-V Raspberry Pi or a RISC-V handheld game system or something. And there are a few RISC-V devices around, but you really need the emulator side on the PC to learn it, and then the hardware side to actually, you know, be able to say, now I can program a game for that bit of hardware over there. And as I say, it doesn't exist, unfortunately. So I'm loading the accumulator there, and then we're going to do transfer C to D, which is transferring the 16-bit accumulator, which is called C, to the direct page register. I'm getting an error because some of my junk code further down is needing the processor to be in 16-bit mode. I've created these macros to switch around. And it looks like I've crashed the processor. Okay. Let's try to do 200. 100 will have overlapped the stack. I thought I'd be okay on that, but maybe I'm not. Oh, there we go. So that looks a bit better. Where's the top line? Why am I missing a line there? Seem to be having some trouble here, don't I? I wasn't particularly aware that messing with the direct page would be causing this much trouble. I mean, my code uses the 0 page, but I wasn't thinking this would happen. Okay, well, let's try that. That should just be the default, so that shouldn't cause any problems. Okay, so that looks all right. I've got a missing character there. The code that's doing this display routines is occasionally getting caught out by the interrupts and missing a character. Okay. So if I load in 1 here, am I using this command wrong? A bit confused here. Have you ever thought about running the homebrew on a flash cart with with a console cam on one of your streams? I did that with the Chibi Akamas game a long time ago. I don't have many flash carts. The tutorials are currently covering 25 systems, and the vast majority of the systems I'm covering now, I literally don't have the hardware to do that. The other thing is, I know from past experience that a lot of these tutorials don't actually work perfectly on real hardware. For example, this Super Nintendo one, I had to make a load of changes to the code to get it to work on this this new emulator, because the old emulator was Messen. This Messen emulator is a lot more accurate than the old emulator I was using, and so it can mean a lot of debugging. And I'll just give you the extreme example. The Chibi Akamas game for the V9K, the V9990 graphics chip, there was a bug in it that didn't show in the emulator that did show on the real hardware, and that took me about a day to fix. Take care, Highlander. Thanks for popping in. I hope you have a good evening. I'm not sure what time zone you're in. Take care now. So the point I'm making about the real hardware is if you come across a bug in real hardware, a bug that you come across on an emulator will probably take you seconds to minutes to maybe hours to fix. A bug that only occurs on real hardware and doesn't occur on emulators will take hours to days to weeks possibly to fix, because trying to identify the bug could really, you could be going back to the technical manuals. Even the manuals may not cover the bug. I mean, the bug with the graphics that I came across, it wasn't documented, and I asked a guy on chat who knew the hardware, and I said, well, the symptoms I'm seeing are that there is a buffer in the processor that's buffering the data. And they said, no, that's not true. It doesn't have one. I know it doesn't have one. I've seen the hardware. And I'm like, well, what's happening looks to me like there's a buffer. I can't explain it in any other way. And they said, well, there isn't one. And I'm like, well, I'm going to carry on as if there is a buffer, because that's the only way I can explain and fix what I'm seeing. And then they were like, oh yeah, well, maybe there is a buffer. And so the point I'm making is you could just devour huge amounts of time to debug on real hardware, debug problems that only occur on real hardware that don't occur on emulators. So it's something I'm scared, honestly, to try at this stage, because you could just see, I could be trying to get a single tutorial working, and that could take me a month. So whereas at the moment I'm making 3 tutorials a week, so it's just a time thing. The standard and the standard that you have to work to produce code that works perfectly on real hardware, compared to the standard that you have to work to get code working on an emulator like this, is very different. And when it fails on real hardware, you're each time you test, you're spending minutes, not seconds. And you probably don't have. I've got debugging tools on this. You've got no debugging tools on real hardware. So unfortunately, it's not something I can consider at the moment. Even the Grime game on the Sinclair QL when I ran it, there was some weird glitch with regards to the keyboard reading and the sound reading, and it was just like, well, it's interesting. I have no idea what causes that. I'm not even sure how to start debugging it. I'd probably have to start stripping the code back. And again, it's like, well, if I'm running around with SD cards, rebooting the machine, plugging them into microdrive emulations, and I don't even know what I'm trying to fix yet, that could take huge amounts of time. So unfortunately, real hardware isn't something that's viable at this time, I'm afraid. It might be, while let's put it this way, I'm doing this as a hobby for a bit of fun, and so programming on real hardware would not be fun, unfortunately. It would be something that you would do if you wanted to make the tutorials to the absolute maximum professional standard, but it would not be fun. I did that for Chibi Akumas because I was commercially releasing it, and although I didn't make any money from it, I was trying to work to a professional standard, but it was very stressful doing it, and there were problems, and often, and you know, with the Amstrad CPC version, I had problems, and it was because my machine has faulty hardware, and firstly, the fault was causing me trouble one time, and I spent 2 days trying to debug that, and it wasn't even a problem with the code. And then once I plugged an extra memory device on to fix the problem with the internal memory, but the extra memory device didn't work the same as the internal memory. So again, I was having problems that exhibited on physical hardware that didn't occur on my emulators. And it wasn't that the emulators were inaccurate, it was that my hardware setup just didn't match anything that an emulator emulated. If you want to see that, check out the CPC Plus Chibi Akumas stream. If you search on my channel, there's it's called like live beta testing, beta test with me or something like that. And I did the CPC Plus Amstrad CPC version, but some of the bugs that were coming up in that they were only happening halfway through the game and things. Another time on the MSX, the MSX version played fine all the way through to the last level. I think even the end sequence of the last level, and then it crashed. And I was just gobsmacked. I was like, how does this happen? And it turned out to be a problem with the disc. When I'd imaged the disc, something had gone wrong. I don't know what, but the disc image wasn't quite right when I wrote it to the real disc. This wasn't an emulated disc. This was a real disc. I think might be wrong. It might have been an emulated disc, but there was nothing wrong with the code. It was just some kind of problem with the image being created. So again, it was like, and that would take me 30 minutes of gameplay to get to the bug. So next day you're spending another 30 minutes playing the game you're utterly sick of. So yeah, real hardware. You got to do it if you're doing commercial releases. If you want to do it professionally, but for me, I just enjoy this kind of thing, just playing around with a bit of hardware, learning something new about an old system. I'm not there's not professional standard money left in this industry, so I'm not willing to program to professional standards, I'm afraid, and test to professional standards. More to point, you know, my Chibi Akumas game sold about 30 copies. I think I spent about 30 days testing it, so it's not really. It's not really a balance. That doesn't really balance out in my book, you know. I would have rather not. I'd have rather spent 30 days relaxing or writing something new or whatever, rather than testing a game, constantly thinking, I've got to hope it works this time. So there we go. Anyway, let's disable that maybe. Let's put another monitor in here. No, I say I am. Thanks off the wall. I am going to keep doing what I'm doing. I fully agree that it's not perfect. If these tutorials were going to be perfect, I should test on real hardware. But most of my videos get like 40 views, and my monthly earnings from YouTube are about $3. It's not. It's not. This isn't a profession. This is a bit of fun, and so I'm unashamedly going to continue doing it as a bit of fun, and I'm only going to test on the emulators. It's just what's viable in this situation. But as I say, I think I think that's just the way it is. So I'm completely baffled about this tcd command. I thought that would work better. But there's lots of interesting, off the wall, there's lots of interesting processes I'm going to be covering next year. I'm going to be taking some quite dramatic leaps with the series. I'm going to be looking at the PDP-11, which is a very old processor from the 70s, server-based processor. I'm going to be looking at RISC-V, as Jesus said. I'm going to be looking at the TMS 9900, which doesn't have a stack, which is baffling. Doesn't have a stack, so we'll have to learn how to program differently for that. So it would certainly be interesting to see this, to see this kind of code running on real hardware, but it would be a lot more work for very little more benefit. Whereas I think if we're looking at processors that are designed in radically different ways to the current ones, I think there is more for us to learn about that than some slight quirk of the hardware of the Super Nintendo that means my current example code doesn't run on it, and the 3 weeks of debugging that took me to figure out what that thing was. So as I say, it's just we're going to skip that for now. Maybe some of the transfer 16-bit accumulator to the direct page register. Okay, I'm mighty confused here. It doesn't seem to be working, and I can't think of anything in my code that would have a oh, maybe I just have. Maybe I've... No. I'm just trying to think what could be the problem here. I thought this should work. So... yeah, so the top byte is always 0. And then the direct page register is added and makes up the bottom 2 bytes. So I don't understand why that's not working. I'm just trying to think, is there anything about the Super Nintendo memory map that means that range is used for something else? Okay, that... I've got the command rimmed out. That's not good enough. I just don't get why this command isn't doing anything. Transfer the value in the 16-bit accumulator to the direct page register D, regardless of the setting of the accumulator memory mode flag. But it seems like it's crashing. Am I using... I can't remember how my code works. Am I using the 0 page to store the X and Y cursor positions? Yes, I am. That's why it's not working. My cursor XY are off screen. Okay, so... STZ cursor X, STZ cursor Y. There we go. So it was working, the command was working fine. I'd just forgotten how my own code worked. and that's why it wasn't showing the result. So if we do LDA #5 STA, I need that to be an 8-bit. There we go. So here the direct page is 0 because we're in default mode. So we're jumping to the monitor there, and then we're loading the direct page with hexadecimal 300 here. And so now the direct page, which is usually known as the 0 page, is now at the alternate address. So yeah, forgetting how my own code worked there. So it's 6:42 a.m. in Japan. So I'm going to be heading off to work in 15 minutes. Got a exciting day of writing emails for mail shots, I think. That's the joys of my day. Let's see if there's just one last interesting command we can play with before I finish. The chat's down to 9 people showing, which is still twice what it was earlier, what it usually is. It's a bit of a relief to. I wasn't very happy with it being at 300. I'll be honest. I don't know what that was about. Yeah, no, thanks, James. No problem. I'm just gonna stick around for a few more minutes, but so the viewer count went up to about 300 because apparently my video was recommended as viewing after some PewDiePie stream, which weird. I can't say I'm happy about that. You know, I don't. My content isn't going to be interesting to very many people, so I don't want a bunch of people coming along thinking it's going to be something else and being disappointed. So I'd rather have a small audience of people who are interested in it than a large audience of people who aren't. So I've got transfer X. I've used these before. They're not very interesting. Transfer the stack pointer to the accumulator. Okay. Yeah. Don't joke it. Don't even joke it, James. I don't think anything good would come with fame, James. I don't think anything good would come with it. So, as I say, I wasn't thinking, oh great, now I have 300 viewers. I was thinking, oh shit, this isn't good. So I'd rather have 5 viewers than 300. I'd rather have 5. Yeah, no, it wasn't good. So I'm just relieved I didn't have 300 people saying, "What's this crap? You suck," you know. So I'd say I'm quite happy with just 5 or 6 viewers, or 2 or 3, or 0 viewers. It's all fine. It's all fine by me. Push effective P. I've already tried that one. Push 8-bit data bank register. Now, how can I test the data bank register? I don't think I can. The data bank register affects everything else. There's 2 registers. There's the data bank register and there's the program bank register. Now, the program bank register is the running code. So, yeah, exactly, Jesus. That's the trouble, isn't it? Yeah, I don't. Yeah. Again, I don't want the trolls. Thank you, as you say, Jesus. It's unavoidable. You can't have the 100,000 views and not get the trolls. So I'd rather the channel stayed very small and just had a handful of views of people who found it interesting. So yeah, I don't want that. So I'm just saying that we got these really interesting commands like the data bank register and the program. What's the other one called? But we can't change the data bank, because if I do, then I'm not going to be able to show anything on screen or use my font or anything, so I don't, unfortunately. Jesus, yeah, sorry. Yeah, I've kind of resigned myself to getting everyone's name wrong anyway, so I'm never sure whether it's better to try and be clever and pronounce people's names in. Yeah, I will do. Sorry, Jesus. I will attempt to do better. My only defense of pronouncing people's names wrong is I live in Japan and I pronounce everything in Japanese wrong and no one understands me and it's very difficult, but I can't do any better. Even when I try, I pronounce everything wrong. That's what I'm trying to say. So, yeah, I apologise. Yeah, unfortunately, my English accent is all too stuck, shall we say. It's not a good thing. It's not a good thing when you leave England. But there we go. That's what it is. But, yeah. I was hoping there was another simple command I could play with just for a moment, just before we ended the stream, but I can't see anything. I'm just wondering how many thumbs downs has this video got. I'm wondering if all of those people have left thumbs downs. Let's just refresh the stream here. Let's just see what's going on. So I'm now watching my own stream, which will probably cause some kind of paradox that's going to destroy the universe or something. But I just want to see if I've got millions and millions of thumbs downs from all of those disappointed PewDiePiers. No. Oh, that's a pleasant surprise. I think I've even gained 4 subscribers. It's unexpected, shall we say. Anyway, well, I'm struggling to find any more commands and it's now 10:02, so I will wrap this stream up. I really appreciate Spain seems to have a big retro community in general, doesn't it? I think MSX is huge over there. I mean, I don't know. I mean, the retro community seems to be big everywhere at the moment in a lot of ways. I think the thing is it seems to be different in different countries, if you see what I mean. You know, the way it manifests. Like in Japan, there don't seem to be any of the web forums. In the UK, they kind of do, but it does seem that there's a very big community of retro gamers in Spain. Anyway, I will be signing off. I hope you all have a good afternoon, evening or morning, depending on what territory you are in. Really appreciate watching today. I will be doing my live stream tomorrow, hopefully. Okay, so we're a bit out there in Florida then, fair enough. It's what time is it there? Is it afternoon? Anyway, yes, irashai. Mata ashta. See you tomorrow. Anyway, thank you for watching. As I say, if you get a chance, please catch my live stream tomorrow. We'll be playing the 7th guest game. Yep. To take care. 5:50 p.m. Fair enough. Bye now.